Hello everyone, myself Bhumi Patel, Assistant Professor at LJ Institute of Engineering and Technology in Department of Electronics and Communication. Today we will study about the different error analysis in the performance of feedback control system. So first of all, the steady state error. Steady state error is generated in the steady state response for the time constants analysis. So what is the steady state error? It is the error, the difference between the input and output of the system during the steady state. As we know, this is the graph for the transient and steady state response. This is the input signal and we can get the graph like this. So this error is known as the steady state error, ESS. It is the difference between the input and output of the system during the steady state region. So for accuracy, the steady state error should be minimized. Now how we can find the steady state error equation? So for that we have take one closed loop system where G of S is our system, R of S is our input signal, and C of S is our output signal. And we can take a unity feedback. Means here H of S is 1 and the signal is negative feedback signal. So for this closed loop system, if we want to write the equation, so we can get E of S is equal to, now what is E of S? It is the error signal, and error signal is generated here. So E of S is equal to R of S minus C of S. Now the final output C of S is depend upon the error signal minus the system transfer function, means E of S minus G of S. Now put the value of C of S in this equation number 1. So we can get E of S is equal to R of S minus E of S, here E of S into G of S, because there is no summing point. So E of S into G of S. So we can get E of S plus E of S, G of S is equal to R of S. Take E of S as a common term. So in bracket 1 plus G of S is equal to R of S. So we can get E of S is equal to R of S upon 1 plus G of S. Here H of S is the unity signal. Now at steady state error, which time it is generated? Time t tends to infinite. So we can write the equation of the steady state error is ESS is equal to limit t tends to infinite E of t. This is the equation of steady state. Now by using final value theorem, we can write the equation in the terms of s. Limit s tends to 0, e of s into e of s. Okay, so ess is equal to limit s tends to 0, s into, we have the value of e of s, so e of s is equal to r of s upon 1 plus g of s. So limit s tends to 0, s into r of s 1 plus 1 upon ts. We can take the system equation g of s is equal to 1 by ts. So we can get limit s tends to 0, ts square into r of s upon ts plus 1. Now, if we consider the unit step input, so r of s is equal to 1 by s, put the value of r of s in this equation, we can get ess is equal to limit s tends to 0, 1 by s into ts square upon ts plus 1. Cancel out s and put the value of s is equal to 0. We can get ess is equal to 0. Steady state error for this system g of s is equal to 1 by ts is equal to 0. So this is the steady state error equation. So the steady state error depends on the input and the open loop transfer function. Now next one is the static error coefficients. The first coefficient is static position error constant Kp. Now we have to find the equation for Kp. So for the unit step input, as you know, r of s is equal to 1 by s. So the steady state error ess is equal to limit s tends to 0, s into, actually equation is ess is equal to limit s tends to 0, s tends to 0, s into r of s into 1 upon 1 plus gs hs. We can put r of s is equal to 1 by s. We can get this type of equation. Cancel out s. We can get ess is equal to 1 upon 1 plus limit s tends to 0 gs hs. We can put limit s tends to 0, g of s, h of s is equal to kp. So equation for static position error kp is equal to limit s tends to 0, g of s into h of s. So where kp is the static position error constant. Now the next constant is static velocity error constant kv. To find out the equation for kv, we can consider the same error equation. ess is equal to limit s tends to 0, s into r of s into 1 upon 1 plus gs hs. Now here we can consider with the unit ramp input, and for the unit ramp input, the value of r of s is equal to 1 by s square. So put the value of r of s in this equation, we can get ess is equal to limit s tends to 0, s into 1 by s square into 1 upon 1 plus g of s h of s. So here we can get limit s tends to 0, 1 upon s plus s g of s h of s. So ESS is equal to limit s tends to 0, 1 upon s into g of s into h of s is equal to kv, where the kv is equal to limit s tends to 0, s g of s h of s, and it is known as the static velocity error coefficient. Now the third coefficient is static acceleration error constant Ka. Same like the steady state error of the system with unit parabolic input, and it is given by R of s is equal to 1 by SQ. This is the types of the input signal, and it is the Laplace of this parabolic signal. So we have the general equation, error equation ESS is equal to limit s tends to 0, s into 1 by SQ into 1 upon 1 plus g of s into h of s. So we can get limit s tends to 0, 1 upon 1 s square plus s square into g of s into h of s. So it is the static acceleration error constant equation. So ESS is equal to limit s tends to 0, 1 upon s square g of s into h of s is equal to 1 by Ka, and we can get Ka is equal to limit s tends to 0, s square g of s h of s. So this is the static acceleration constant. Now example for the open loop transfer function of the unity feedback system is given by g of s is equal to 50 upon 1 plus 0.1 s into s plus 10. We can find the static error coefficients Kp, Kv and Ka. So for that we can put equation Kp, Kv and Ka and put the value of g of s in this equation. So first equation Kp is equal to limit s tends to 0, g of s into h of s. Here the value of g of s is given and the feedback value is unity. So h of s is equal to 1. So limit s tends to 0, 50 upon 1 plus 0.1 s plus 10. Put the value of s is equal to 1. We can get limit s tends to 0, 50, 1 plus 0 and 0 plus 10 is equal to 50 by 10 is equal to 5. The value of Kp is equal to 5. Now next one is the Kv, and the equation of Kv is equal to limit s tends to 0, s into g of s into h of s. So limit s tends to 0, s into 50 upon 1 plus 0.1 s plus 10. Put the value of s is equal to 0. So 0 into this term So we can get answer kv is equal to 0. Now the next one is the ka. Ka is equal to limit s tends to 0 s square g of s h of s, and the value of g of s is equal to 50 upon 1 plus 0.1 s plus 10. Put the value of s is equal to 1. So 0 into 50 upon 1 plus 0, 0 plus 10. So the final answer of Ka is equal to 0. So we can get the value of error coefficient Kp is equal to 5, Kv is equal to 0, and Ka is equal to 0. So this is the final answer of this example. Thank you everyone. If anyone have doubt in the error analysis, then contact me in this email ID.